Hello everyone across the globe, welcome to Prince D TV, and we will be on the way very shortly. And we are back, brighter and better, reconnected and ready. Alright, once again, a warm welcome to the Prince D TV. As usual, yet to another exciting tutorial. And of course, without wasting much time, we are going to dive in straight away. Inverse of a function. So we began touching so many other aspects of a function, and today I want us to see something specific, and from there you can boast that you've had some much more understanding when it comes to function. So the inverse of a function. Here, from its name already, inverse, opposite, the difference, the other way you can do something. So mathematically, when we talk of the inverse of a function, we are simply looking for a rule, that rule whereby we will be able to follow that rule and be able to map, relate elements from the codomain or the range to the elements of the domain. Elements from the codomain or the range, we look for a rule, we'll map them back to the elements of the input set, and that is the domain. So, for example, having a function, as this, f, such that x maps onto 2x plus 2. Now, what is the inverse of such a function? So, first of all, we have a denotion for the inverse of a function. So if this is f of x, so the inverse will simply be f raised to the power minus 1. So the minus 1 simply means inverse. Alright, again, if you have another function f such that a maps onto b, how can you look for the inverse of such a function? So like we said earlier, for the statements, we are just simply looking for those elements which are in B, the codomain, how we can map them back to elements of the domain. So, using arrow diagrams, for example, using arrow diagrams, we have, let's say, A and B. So, this is a function f where a maps onto b. So this is set A and this is set B. Now the inverse is simply those elements of B, looking for a rule that we can map them back. So this will be the f inverse. So that's the general idea when we talk of the inverse of a function. Now, for a case as this first example that I gave here, there are certain rules. So here we are looking at it properly mathematically, how we can look for the function. Just like we always use basic mathematical know-how and operations, we will be able to calculate the inverse of a function like this. So without wasting much time, we'll look for the inverse of that same function. The inverse of that same function. Rules that you have to note. You are given a function like this. The first thing, you have to let the function be y. So let f of x be equal to y, or let y equal f of x. Secondly, make x or your unknown. Remember I told you it must not be x, it can be any letter. So in this case, make the unknown, in this case we have x, you have to solve and make x to be the subject of this equation. So x has to be on one side, x should be equal to something. Then finally, when you make x the subject of the equation, you change now y. Remember, we are letting y equal to all of this. Finally, to get the inverse, remember this function doesn't have y. So at the end, any place where you have y, you substitute y with x. So that's it. We'll do it right away. So f of x equal 2x plus 2. This is f of x equals plus 2. Now, let y equal f of x. What's our f of x? Our f of x equal 2x plus 2. So, y equal 2x plus 2. That's the first step. We are letting y equal to the function. Secondly, let's make x the subject. So x has to be like y. Our goal is to make x to be like y equal to something. So simple algebra. Remember, we can send this man this way. Y, when a number crosses the equal sign, the sign changes. It is plus 2. When it comes this way, it becomes minus 2. And we are left with 2x. 2x. One more step. X is still attached to a number, and this is multiplication. And with multiplication, we can simply divide all through by that number being multiplied to x. And of course, our number is 2. 2. Next, we can cancel out. And of course, x is alone. Y minus 2 over 2. So, remember, we can still put our x in front. X equal y minus 2 all over 2. Y minus 2 all over 2. We are almost done. It's time for a quick intermission. We'll be right back. So, I told you, remember the last step, anywhere we meet y, we change it to x, because the original equation or function is having an x, no y is there. Why we are doing it like that? Because we want to change. That is the rule for you to look for the inverse. So, f inverse, f to the power negative 1 of x is simply equal to, we replace the y with x, x minus 2 all over 2, and that is of course the inverse of that function. As simple as that. All right, so that is the inverse. Now you can be given a question, look for, this is f, you can be asked, look for f inverse of 0, f inverse of 2. What do you notice? We have been given just the function. We were not given the inverse. Now we have looked for the inverse. So if they went further, it's just like looking for specific values of functions, right? Now this is f inverse. It is not f of 0, it is f inverse. So what you have to do is to do exactly what we have done a few minutes ago. So you must look for the inverse first. Then what do you do? After looking for the inverse, you substitute the values now into that inverse. So with that said, we still have our f inverse. So our f inverse of x is x minus 2 all over 2. So f inverse of 0, anywhere we see x, we substitute 0. 0 minus 2 all over 2. 0 minus 2, our number line is minus 2 all over 2. Minus 2 divided by 2 is negative 1. So f inverse of 0 is negative 1. And lastly, but not the least, f inverse of 2. f inverse of 2 is equal to x, we replace it with a 2 minus 2 all over 2. 2 minus 2 is 0 all over 2, and 0 divided by 2 is 0. So our f inverse of 2 is 0. And we are done. That is exactly the way to look for the inverse of a function, and of course looking for the specific value of the inverse of certain values. Thank you so much, and that brings us to the end of this incredible and outstanding tutorial looking for the inverse of a function, and of course looking for the specific values. I remain your boy, as you already know, Prince D. Much love and God bless.